All right. In this video, what we're going to be looking at is the difference between our vertex form and the intercept form. So if you guys remember, we already covered this slide when we did our vertex form. And the big idea when we learned this was that when we have kind of an x minus 2 here, that means my vertex is going to have a positive 2. But then this number on the outside that's not with the x doesn't change at all. So when we saw an x plus 4, my vertex had a negative 4 for the x, and then that minus 3 stayed the same on the outside. So the vertex form helps us know what the vertex should be. Today we're going to learn this form, and it's called the factored or intercept form. All right. Now, if you look at this one, this looks like f of x equals a x minus p parenthesis x minus q. So just like our vertex form showed us the vertex, our intercept form is going to show us what our x-intercept should be. This rule stays exactly the same. If you have a plus a, it opens up. If you have a negative a, it's going to open down. All right, so here, when we look at our graph, right, each of our forms kind of tells us something important. So our vertex form showed us the vertex. Our intercept form is going to help us locate our intercepts very easily. And so if you look here, it says P and Q are your x-intercepts. So that's telling us these 2 points here, this point and this point on my graph. All right. So here's just kind of a few important things. Graphing quadratics in intercept form, it's just another way to write the equation. All right. Intercept form is its factored form. So you're just going to hear these two words kind of interchanged with each other. All right. And when you have your intercept form, right, you're going to be able to quickly and easily get what the two x-intercepts should be. So on your notes sheet that you hopefully have with you or that you wrote out in your notebook, this is our intercept form, if you go ahead and write that in. And what this tells us is that my intercepts are P0 because it's an x-intercept, so the y has to be 0, and Q 0. Okay. And just like what we did with our vertex form, anything in with the x, you take the opposite side. All right. So let's go ahead and look at an example of this. All right. So if I were to look at the graph or the equation y equals negative x minus 1, x plus 5. All right. So right away I see a negative in front. That means my a value equals negative 1, which means this graph is going to open down. All right. Then I see I have x minus 1. Well, that tells me I have an intercept not at negative 1 because the equation has the minus. My intercept is at positive 1, just like what I did with my vertex. And then here I have an x plus 5. So my equation here, or my intercept here, is going to be negative 5, 0. All right. Now, these are my x-intercepts. Right? But also remember what we've been talking about. These two numbers, the 1 and the negative 5, actually represent the roots, the zeros, the x-intercepts, and the solutions. So intercept form kind of gives you the answers right off the bat. Now, one more example of this. I see here a 3, so that means I'm going to open up this time. All right. It's also going to be more narrow. Just kind of throw out some of our facts from last week. And then my two intercepts here are going to be a negative 5, 0 and a negative 9, 0. Okay. All right. So here is, I'm just going to do one of these with you. All right. Because I don't want you guys to forget, we still have Desmos, right? So even though we're kind of learning some more facts about this stuff, we are going to still use Desmos to help us. So if I were to graph this, I see that my x-intercept should be at -6, 0, and my other x-intercept is at -2, 0. So I'm going to go ahead and graph both of those dots. I also know that this one is going to open up because it's just a +1 there. All right, so take a second and just write this down somewhere in your notebook so you can kind of draw a sketch with us. So now that we see what I know my intercepts are, we can just verify that in Desmos. I have at -6 and at -2 are my two intercepts. But this is asking us for all the other information too. So I'm looking at my vertex, which is here at -4, -4. So I'll go ahead and plug that in. All right, and I'm going to go ahead and sketch it. And then remember, we've also talked about the fact that my axis of symmetry is the vertical line that divides my parabola in half, right? So I'm going to just have that right there. And remember, vertical line we have to write as x equals, and this is the line x equals -4. Also, let's say you're not sure you wrote that correctly, right? You're going to go over to Desmos and you're going to type in x equals -4 into Desmos and make sure that that works, which it does look like the line that's dividing it down the middle. All right, now this is definitely a minimum value, and this graph doesn't have a maximum. It's one or the other, okay? And my domain, always, all real numbers. And then my range are all of the values starting at -4, but then getting larger. So I'm going to go ahead and draw in that parabola right there. Okay. All right, so you could try this one if you wanted to. We're actually going to have a problem in the homework that's going to make you do your own. All right. So now if we just go ahead, the last thing I want to talk about is a graph has a 0 at x equals 5. What would the factor be? So this is just working backwards a little bit. All right. So if I have a 0 at 5, what that tells me is that my graph is actually going to be crossing the x-axis at the point 5, 0. All right. It might also say that this was a root at 5, or it could say solution at 5. The factor then is going to have to be x minus 5. All right. Likewise, if I told you that a solution is at -1, right? -1, my factor is going to be x plus 1. Remember this big idea from vertex. Anything in with the x, you change the sign. And then the zero always throws people slightly. If I have a parabola that crosses at 0, right, we still have to have a factored form for it. So maybe to start with, you want to say, okay, I want to write x minus 0 just to kind of help you realize that x minus 0 is just an x. So you would have an x out in front of the problem if you have a solution at 0. Let's say this one was at 4, right? Then I would say x minus 4 next to it. And so you would see it written like this, with a singleton x out in the front, and a singleton x out in the front means you have an x-intercept at 0. Okay? All right, so if we just I want to look at one of those quickly. If you look at this one here, right, I see an x in the front, 0. I see a x minus 4, that tells me 4, 0. And then everything else Desmos is going to help us do, all right? The 2, I know that this is going to open up because of the 2. But everything else you're getting because you're going to type into Desmos and be able to label your key parts.